All right. Hello, everybody. Welcome to CU Data Week. We're very excited to have everybody. Just as a quick warning, we are recording this session. So if you don't want to be on camera, it's totally okay if you shut off your camera. And yeah, I just wanted to give you a warm welcome. My name is Laura Grau. I work at the Center for Innovative Design and Analysis, and I'm one of the co-hosts here for Data Week. We do have quite a few events this week that I wanted to bring to your attention. Let's see if so today is the first Stats Talk with the wonderful Connor, who's on the call. And we have today basic statistics using R and creating cool figures in R this evening. Tomorrow at the same time, I'm teaching basic statistics using SAS. And then in the evening, there's a 2-hour session with analysis workflow using Git, Python, and Jupyter. That StatsTalk actually requires prior registration because we had to limit it so it could be more hands-on. Then we have on the second, Introduction to Microbiome Data. If you are participating in StatsFest from Thursday to Saturday, I highly encourage you to go to the microbiome talk because we will be working with microbiome data. And then last but not least, on the third, we have Working with a Statistician, which is a lecture co-taught by 2 of my mentors. And it's really meant to be an introduction on how to collaborate well with biostatisticians. And then at the end of the week, from Thursday to Saturday, we actually have a competition. It's called StatsFest, where for almost 48 hours, you'll be programming using microbiome data. And we'll have really cool prizes at the end, from wearable activity monitors to wireless headphones to electronic readers. If you haven't registered but would like to do so, feel free to email me. My email's on the website, and I'm happy to add you to our list. But other than that, I want to hand it off to Connor, who will be teaching basic statistics using R. And I hope you guys enjoy Data Week. Connor, take it away.
All right. Thank you, Lala. I'll go ahead and share my screen. So I know we've got some people logging on here, but I'll go ahead and get started. As Lala said, this is a CU Data Week, so we've got a nice variety of different seminars and activities going on. So I encourage you to check out more than just this talk if you are interested in data. But this talk for this next hour is going to be focused on basic statistics using R. Again, my name is Connor Jackson. I'm a research instructor for the Center for Innovative Design and Analysis. I also teach the short course on basic statistics and data science for bench scientists in the fall. So if that's something that maybe you're interested in, or this class maybe has piqued your interest, that's something that's a little bit longer at 6 weeks. So something that might be worth thinking about. One thing that I will just kind of make as a caveat is that 1 hour is not a lot of time to discuss either statistics or R. So I'm going to do my very best to kind of give you a nice introduction and give you some resources so you can kind of have the tools and a little bit more confidence in interacting with this software than you did before. So with that, let's go ahead and get started. So the outline for this talk, again, it's hard to know kind of where everyone is starting with. So I'm just going to start with the basics. Assuming if anyone has any questions about downloading R, all of the examples, we're going to use RStudio. So again, for those of you who may not be familiar, RStudio is essentially an environment in which you can use R, but it's a lot more user-friendly and a lot more convenient than just kind of coding in R. So I'll show you what that looks like. And then for this presentation, and also for Lala's presentation on Wednesday, we'll be using the same exact data set. So my hope is that by giving you kind of a consistent data set that maybe you're familiar with, it'll encourage you to go to the SAS talk on Wednesday at noon, and again, sort of providing that consistency. So what I would like to do is show you how to download that data in the event that you're interested in playing around with these kinds of things yourself. Also, the code in this presentation will also be uploaded. So we'll make sure that you have all of the resources you need to be successful. And then from there, we'll actually get down into the specifics. So I'll show you how to load data into R, and then kind of with that, we've got 4 data sets to look at, kind of 3 different kinds of data to look at. So I'll give you a description of the data, and then we'll also talk about developing hypotheses, right? So generally speaking, because this is a seminar that's focused on statistics, we generally kind of want to have a motivation for why we're using R in the first place, right? So we'll describe the data and then kind of talk about maybe some hypotheses that we could test from the data. And then from there, just kind of following the general course that a lot of statisticians will do when they interact with data. So once we have a hypothesis, we kind of want to look at the data. We want to understand, is there any missingness? Are there any outliers? Things like that. And then finally, we'll talk about just kind of some basic statistics that you can perform in R. So I'm kind of assuming that you have some familiarity with some of this terminology, but again, I'll do my best to kind of give you a basic summary of what we're working with. And again, my short course, we go a little bit more into the details of, for example, how you can do stuff in R and how you can do stuff in Prism, and how those are different. But for this particular talk, we'll focus on R. And again, if you have any questions, you're more than welcome to put them in the chat, and we'll have time to answer those at the very end. So, like I said, today we'll be focusing on just kind of simple statistics, so things like t-tests, chi-square test, and simple linear regression. So, like I said before, we'll start with just, again, not knowing where everyone is at with respect to R. We'll talk about how to download R, and then, so I'll actually share my screen and we'll go through that. And then I'll also show how to download our studio, and then I'll show you how to download our example data, and then we'll come back to the slides. So let me go ahead and stop sharing my screen, and then I will switch over to my desktop here. Okay. So again, if you have not downloaded R, again, you will want to start here. I have the link in the presentation, but you can also just Google the letter R. Oftentimes that will bring you to the website, or you can Google R software. Once you're here, you'll click on the To Download R button, and it's going to ask you to find a crayon mirror, which the first time I was interacting with R, I didn't understand what this meant. Just again, for those of you who have not downloaded R, the recommendation is that you generally just kind of scroll down and find a location that's close to where you currently reside. I picked the University of Kansas. I was born in Kansas. That's the reason why. That's not really go Jayhawks, I guess. But there's not really a reason why you shouldn't pick any of the others here. But the general convention is that you choose one that's somewhat close to where you currently live. So once you've done that, let's say that you'll pick this KU one. From there, you'll have to pick either, depending on what you're working with, either a Mac or a Windows. You'll click the link, and then you'll get the option either to download the package and then just a kind of standard software download from there, or with R for Windows, you kind of have this install R for the first time button, and you'll go from there. The one point that I do want to make is that if you are on a Mac, it does ask you, this is a lot of text, so I just want you to pay attention here. It does require that you download something called Xquartz in order to interact with certain packages. So just be mindful of that. And that is something that I included in the presentation as well. So just something to pay attention to. And then other point to make is that R continuously releases different versions. And so this particular version was released in November. And sometimes, like, a good question that some people will ask is, how often do I need to update R? Oftentimes, it's not necessary to update every single time a new release comes out, but generally speaking, what you'll find is that sometimes you'll have packages that you're interacting with that may require a certain version, or they may not work under an older version. So unfortunately, there's not really a straightforward answer, but I've found, generally speaking, that I try to update it at least so it's within a year or two, and really goes down to how all of your packages are working. So that's downloading R. And then once you download R, the recommendation that I have is to never open it, which the reason why I say that is because R by itself is kind of, at least in my opinion, is not particularly user-friendly. And that's why a lot of statisticians kind of my generation are a big proponent of RStudio. So once you've downloaded R, you can go to this RStudio. You can just Google RStudio. Again, I have it on our on the link on the presentation, but you'll scroll down and you can download RStudio Desktop. It's completely free. And again, it's it actually will auto detect your machines. You can see here that it's detected that I'm giving this talk on a Mac. And then from there, you can kind of have what I think is a lot more of a simple interacting with coding. So that's, again, just to kind of get you started. The other sort of last point that I want to make before we get back to the slides is GitHub. So you do not need a link. You do not need a login to access this information at all. The point that I just want to make again is that after this talk, if you're interested in actually interacting with the data and exploring the data for yourself, which I highly recommend, you'll want to actually get the data. So again, this link will be in the presentation. And all you will do is just click on this lunchtime basic statistics using R folder. And then we have this public data public SAS folder. So again, this data actually came from a free SAS repository. So it's just free data set that we can kind of interact with. And so when you're ready to download it, you'll just click on the name of the file. And there are a few ways you can do this. You can click view raw, and then it takes you kind of to this white page. And then at least for a Mac, all you have to do is click save as, and then you can download it. And I'm seeing something in the chat here. Let's see. Do some older packages no longer work with new versions of R? Would you need to have different R versions downloaded for different projects in this case? So that's a really excellent question. So yeah, there are definitely cases in which older packages no longer work. I think generally speaking, what you will find is that you'll get like a warning, like for example, on my personal computer, which I don't really use much for coding anymore, I have a version from like 2018. And so when I load certain packages, it'll say, this particular package assumes that you have a certain version of R. And so it's not necessarily that they will no longer work, but it can kind of depend. And things will get especially tricky, just knowing that a lot of folks here on the call are more kind of genomics or health data inclined. It gets really, really important to pay attention to your versions when you're thinking about using things like Bioconductor. And that's kind of where a lot of packages that you can get that deal with more kind of specifics of like statistical genomics and things like that. So yeah, I mean, it definitely depends on the package, unfortunately, to not give a very clear answer. And there have actually been times where I've had to switch versions of R. Just like, for example, I had a manuscript that came back and I had to go back and into an older version of R just to reproduce something. So yeah, I mean, it's a good point about versions of R to keep in mind. And again, that's why generally speaking, it's good to kind of make sure that it's updated, and you can always transfer your packages over. So I hope that answers your question. And then let's see, can you send the link for the, absolutely. So again, like I was saying, and we'll post this information, but if you want to download the data, you just can right click or whatever on your machine, you save it, and it'll save as a CSV, like a traditional Excel file. The other point that I want to make here is if you click on this CARS data set, it doesn't look the same, but all you have to do is click raw. And then once again, you can just click save as and save it. So we had another comment in the chat about having the link here. So I'm going to post that in the chat right now. That way you can just have it later for your convenience. Oh, Lala's already got it. Lala's on top of it. Thank you, Lala. So that is sort of the basic introduction. Great question so far. I'm going to switch back to our talk here. Apologies for the back and forth. So again, just as a reminder, download R, and then from there, select your crayon mirror, and then also download RStudio. And then from there, you can open RStudio. And the point, again, that I just want to make is that you have to download R in order to use RStudio. So I recommend that you download R first. And then just as Lala put in the chat, this is where you'll find our data. Data has come from SAS software. So again, if you attend our lunch talk on Wednesday with Lala, you will interact with the same data and find that the results are the same. So encourage you to check that out if that's interesting to you. And these are, again, just the instructions to download the data. So let's actually talk a little bit more about how to use R. So first thing you're going to do is open RStudio. Again, you are not required to actually use R itself. There'll just be separate applications on your computer. And then once you've gotten into R, you'll have to do what's called setting your directory. And so in this particular case, if we downloaded our data from GitHub straight to our downloads folder, so you'll want to make sure R knows how to access those folders. And this can actually be done in a point and click kind of way. So I'll show you how to do that as well. Again, when we wrote these kind of talks, we want you to kind of feel empowered to interact with R without having any R coding experience. I'll kind of show you a point and click opportunity to get your data in and start playing around with it. So like I said before, we have four data sets. Two have to do with infant birth weight. One of them has birth weight treated as continuous. So in that case, it's birth weight treated as grams. So we'll kind of look at it's continuous data. So it's a variable that has numbers between like 200 and 5,000 grams. And then for the other data set that we have that has birth weight actually just has birth weight as a binary variable. And so again, instead of a continuous variable where we're actually looking at a range of individual measurements for each infant, this is just basically a categorization of whether or not a particular infant either had a low or high, or actually a low birth weight or not a low birth weight. And then finally, we have two more data sets. We have a CARS data set, which is looking at cars from 2004 with various variables that you might have on cars, things like highway miles per gallon, weight, things like that. And then finally, we have a fictional data set of a class of I think they're middle schoolers. It's like 19 fictional kids, and just looking at things like age and height. So we'll look at that one as well. So first data set, again, as I said before, we know what our data is, but generally speaking, if we're conducting statistics, we have a hypothesis that we want to test. So as I said before, we have both continuous and categorical data to work with. We have a birth weight in grams. So again, that's each infant has an actual value assigned to their birth weight. And then we also have birth weight as a categorical binary variable, yes or no, for low birth weight or not low birth weight. And then in both of these data sets, we have maternal smoking status. So an obvious hypothesis would be, is there a relationship between infant birth weight and maternal smoking? And so, generally speaking, we kind of have a pretty good understanding about this, but again, it's kind of wanting to test something that we already kind of understand what the result might be, just for the seminar. So the first test that we will conduct is looking at the relationship between maternal smoking status and low birth weight. So again, those are two categorical, or another way to describe them is grouping variables. So again, we're just interested to see if there is any kind of relationship between smoking status and low birth weight. Again, both binary variables. And for just as a reminder, when you have a test like that, that's generally going to be a chi-square test. So you're looking at two categorical variables. Briefly, the chi-square test is a little bit different than something that you may have heard of, which is also called the Fisher's test, which oftentimes is more appropriate for small sample sizes. But again, don't have a ton of time to get into the nitty-gritty of the statistics. So we'll just talk about the chi-square test today. And then a second test, again, might be, now that we have continuous data for the infants, could be, what is the actual relationship between maternal smoking status and birth weight? So that can either be a t-test, which I'm sure a lot of you are familiar with, or what we call a non-parametric test, which is either the Wilcoxon or Mann-Whitney test. So again, we'll look at all of that and we'll talk about the motivations for that as well. And then finally, for our other two data sets, we have both continuous and categorical data. So for both of these data sets, we'll focus on continuous data. And so again, what I mean by that is just we have an actual value assigned to each measurement. And so for the cars data, we'll have both highway miles per gallon and city miles per gallon is what we'll look at. And then for the class, we have height in inches and weight in pounds. So for the cars, a reasonable hypothesis might be, I'd like to know if there's a difference between highway and city miles per gallon. So it might seem reasonable based on what you know that generally speaking, the highway miles per gallon is going to be higher than the city miles per gallon. So that's something that we can test. And in this particular example, these would be, I would categorize them as two paired continuous variables. So in this particular case, for example, each car has both a highway measurement and a city miles per gallon measurement. And so what we want to do is we want to know if there's a difference between those two. And so that's what we'll test. And those are called paired tests. So we'll talk about that as well. And then finally, is there a significant relationship between weight and height of school children? So here we have two continuous variables, but we're looking at the trend, right? We want to look at the relationship between weight and height. And so it may be a reasonable hypothesis that the taller you are, the more you weigh, right? And so we'll look at that hypothesis as well. So that is my introduction. So let's switch over to R and actually get started. Okay. So if you go to that link that Lala nicely shared, thank you again, Lala, you will find this R code. And so what you will do is once you open that and you download it, you can tell either Windows or your Finder in Mac, whatever you're using, to open up in RStudio. And this is what your environment will roughly look like. So in the top left, you'll have your R script, which is where all of your coding actually goes. In the bottom left, you'll have your console. So that's where you'll see we'll have a lot of our information that we kind of interact with throughout the rest of the talk. Top right, we have our global environment. So that is where our data and all of our kind of different structures will go. And I'll show you kind of what that means in a moment. And then this bottom right kind of is a different things. You can see plots, you can see where your files are and things like that. So just as a quick, I've already coded this up, but like I said, I wanted to show you how to upload data into R without requiring any coding, because again, I think that's just kind of a nice tool to have. So as I alluded to earlier, you're going to want to make sure that you're in the correct directory. So you'll click up here at the top, you'll see session and then set working directory. I'm seeing something in the chat. Let's see. So I don't have a script open yet. How do I do that? So excellent question. Thank you. So if you want to open a new script, either you can open something from your downloads like in the chat, but if you'd like to open a new script and start, trying new things, all you'll have to do is click File, New File, and then R script. And then you can have a new script to type. You can copy over the code that I have here. It's a great question. Thank you. So again, you can go and set your directory. You're not required to do this, but it's something that is important to keep in mind because sometimes it can be confusing where your data is. So I'm going to click again. I'm going to go to my downloads. I'll, just point and click. And now what you can see, I want to point out two things. Number one, you can see that I have in the bottom of our what's called our console, it's now telling me that our folder structure says that I'm in downloads. And then here, if you look at the far right, you can see the what is a giant mess of my downloads folder. But I have, everything is sorted alphabetically. You can kind of sort by time, all that good stuff. And what you can see here is that I have all of the files that I downloaded earlier. So once I know I'm in the right spot, I'm going to go up here where it says import dataset. I'm going to click from text base. So the point that I want to make here, and then again, just like most things, there's a variety of ways to do this, but this is the way that I do this. Because we have a .csv file, we'll use this from text button. But if you have a .xlsx, if you have an actual proper Excel file, you can click this button, and then you can upload Excel files. You can actually upload SAS files directly. So just keep in mind, if you click this from text base button and you try to upload an Excel file that ends in .xlsx, it's not going to work. So just keep that in mind. So now, again, this is just for demonstration. Once you've selected your directory and you said from text, let's just upload our first data set here, birth weight. I'm going to click on it, and then I'm going to click open. And then it takes me to this little page, right, where this is our input file, our input file. This will look like what we saw, sort of our raw file when we looked at GitHub. And everything else sort of default should do what you want it to do. So the important consideration that I want you to make is that as you upload your data, you're going to want to have column headers, right? You're going to know what all of these variables are called. So by default, R actually assumes that the first row is going to be the name of your columns. But if you don't have that checked, it's going to just arbitrarily assign them V1 variable 1, V2 variable 2. So what the important part of this page that I want to stress is just make sure when you look on the bottom here, make sure this looks kind of like a data set that makes sense to you, right? And then you'll want to name it something that makes sense. So by default, it's going to give you the name of the actual file, and that's what we'll use. But something important to think about, right? Especially if you have like a really long file name, you can change the name here, but we'll keep it as birth weight. Let's see. We just had a chat here. Trying to this link. So we had someone with a question of downloading the files. So let's see. Are you on a Mac or a PC? Okay, so we're having a few people with the same issue. So and then when you're on this page, and I'm really glad you brought this up. So when you're on this page, when you try to right click, or on the Mac, I don't remember what it's called, and click Save As, does that work for you? I'll give them as text. So a text file is okay. So yeah, so a text file is okay. And then for the folks on the Mac, what happens when you try to right click and click Save As? See if let's see if it has a text file as well. Okay, so okay, so a text file is totally okay. It should read in the same as a CSV file, so no worries about that. If for some reason you are having issues with downloading it from GitHub, that's totally okay. I'm going to put my email address, or Lala, do you mind putting my email address in the chat? Thank you. So yeah, please, I definitely
want to put my email, and I can send the data sets if people email me, and I'll just respond with the data sets while you keep talking.
Perfect. Thank you very much. Yeah. So we definitely want to make sure, again, all of you have what you need to feel comfortable with doing this. So again, thank you for the questions, and Lala will make sure that you can get the data that you need. I'm sorry that it is not working the way that we wanted it to. So again, text or CSV file, either should work. It's the same exact process. So, and you'll just click import data set and text, and regardless of whether it's .text or .csv, it should load in just fine. Just keep in mind, you want to make sure your data set looks like how you want it to. And then, so this is our data set, right? So if we had opened it in Excel, we would see something similar to this, right? We have a bunch of rows which correspond to a particular infant. And we have a column for low birth weight, again, yes or no, whether or not the mother was married. We have an age group for the mother, race, whether they drank during the pregnancy, whether they smoked during their pregnancy, and some kind of education variables. So that's kind of a basic look at the data. One way that I like to interact with R is by using what's called tidyverse. And so again, I know I'm throwing a lot of information at you now, but I will say that there's a lot of really great resources out there about tidyverse. The library actually teaches a class about it as well. But when you're new to R, for example, if you're Googling something or you come across a package and it says you need this package, right? So I want to show you how to do that. So in this particular case, I'm going to use the tidyverse package. And so in order to, for those of you who are new, you're going to go up to the top and you're going to click Tools, Install Packages, and then you'll just type the name here, right? So in this particular example, I would type tidyverse, and then I would click Install, and it would install it for me. I'm not going to click Install now just simply because I already have it installed on my computer, but that's what you would have to do. And then it's going to load our various packages that we need. So right off the bat, again, for example, with birth weight, our hypothesis, right, primarily is that we're interested in what's the relationship between birth weight and maternal smoking status. So again, I know this is fast. I know this is a lot of information. If you have specific questions about this content, please feel free to email me. But essentially what we're doing here is we're taking our data set. In this case, this is our birth weight data set where we actually have the weight in grams for each infant. And then we're using a concept which is called piping. So the idea is that we're taking one thing and we're kind of pushing it through different manipulations in order to get something, some sort of like summary or augmentation of the data. And so in this particular example, what we're saying here in our code is that we're taking birth weight, which is the name of our data set, and then we're piping it through and we're grouping it by, so this function is called group by mom smoke. So that's the name of our variable that describes whether or not mothers were smoking during pregnancy. And then we're going to use this function called summarize. So again, I highly recommend that you look at tidyverse, and I'll at the end, I'll show you a really great free textbook that you can download to interact with it. But I think that a lot of this is pretty intuitive, right? So what you're saying is, I want to know if there's a difference in mean birth weight and the standard deviation of the birth weight kind of between mothers who smoked and didn't smoke. So what I'm going to do is I'm going to highlight this code. I'm going to click run. And here, what you can see in the bottom in our console, this is where we get our results. So we can see that, and just for your reference, a 1 refers to mothers who were smoking during pregnancy, and a 0 refers to mothers who were not smoking during pregnancy. So what you can see here is that, again, for 0, for no smoking during pregnancy, we see on average a higher birth weight. And for, again, 1, we have the mothers who were smoking during pregnancy. We see on average a lower birth weight and kind of similar standard deviation. So again, that's just kind of a first way that you can start interacting with your information. You can put other summary measures here. You can put medians, quartiles, all stuff like that. And then the other point that I want to make, and I actually use this a lot, is there's this package called Table 1. And so again, just as I said before, if you'd like to download this, you'll just click on Tools, Install Packages, and then you'll just type Table 1, and it'll come up for you, and you'll click Install. What I like about Table 1 is that it kind of gives you this a nice summary of your data kind of very quickly. The other thing that's nice is that these are actually called HTML like tables. So they copy over really, really nicely into Excel or Word. So that's just something to keep in mind. And here, for example, what we're saying in this line of code, which is line 23, we're taking the table 1 function, which we've just downloaded, and then we're looking at both the maternal weight gain, maternal education level, the sex of the child when they were born, and we're interested in how that looks based on the maternal smoking status. So that's what this vertical bar means in this particular case. We're interested in sort of stratifying out whether or not they were smoking or not smoking. And then you can kind of look at that summary data there. So that's one kind of way. And then again, if you can attend the SAS talk, you'll see another way, but the results are identical. So let's get back to our actual statistical tests, right? So I'm going to use the same table 1 function again, just to summarize the data. Here, what I want to point out, so I'm just interested in the relationship between low birth weight, which again is a categorical variable, and smoking, which is a categorical variable. And here, why I've done this is I want to highlight the fact that we have some missing data. So we'll want to take that out. And that can be really common with data that you're working with. And again, dealing with missingness could be its own seminar. But in this particular case, I'm just going to take that out. And so again, there are a variety of ways to do this. This is one way to do it. So using, again, the tidyverse kind of, I'll call it a vernacular for lack of a better word. You start with the name of the data set, and then you'll see this a lot in R. The arrow with the dash on it basically means to assign something. So I'm saying I'm going to assign this change data set to the name birth weight. And in this particular case, what I'm doing is I'm just filtering out any particular case in which the smoking variable is missing, right? So it's an example in when smoking is not a yes or no. So in R, what you'll find is that the exclamation point next to an equal sign means not equal to. So what I'm doing in this data set is I'm saying, I want anything in the data set that's not equal to a missing cell. And then once we do that, and rerun the same exact code, we can do that up here. What you find now is that we just have the 2 categories. And the other point that I want to make is you can see that, maybe there is a difference, right? You're saying that for the mothers who did not smoke, it was 7.9% that were low birth weight versus 9.2%. So we also have a massive sample size, so over 90,000 subjects, which is huge, and that obviously will probably inform whether or not something is significant or not. So another way to visualize your data is I'll just notice here, this is the table 1 function. This is just the table function. So table function is just something that's based in R. You don't need any packages for it. And this information will be identical to this information here. You can see that the numbers line up. And then for actually conducting the chi-square test, all you will do is use the chi-square function. And so you can, if you're not sure what the name of a function is, you can Google it, just say chi-square test R. It's chi-sq.test. And then you just have to tell R the names of the variables that you want to look at. And so in R, if you would like to pull the column from a particular, let me see here. So we just got, someone is getting some errors. Let's talk about that at the very end. And again, if we don't have time, please email me and I'm happy to figure out what the specifics are. Although it sounds like that might be an issue with the naming of the data set. So again, let's talk about that at the end. But here in this particular case, when you're using R, the $ after the name of a data set will tell R that you want to look at that particular column. So what I'm saying here is that I want to know what the relationship is between low birth weight and smoking status. And then I'm going to run this either on a Mac, I just hit Command Enter, or you can highlight it and click Run here. It's exactly the same. So here we have a highly significant p-value. So it's 9.46 times 10 to the negative 10th. So highly, highly, highly significant, well below our traditional p-value, 0.05. And the other point that I want to make is this correct equals false argument. I won't get too much into the weeds with this, but the point that I want to make is that with a chi-square test, you can make corrections, and this is purely based on your sample size. And so generally speaking, I just want to point, and again, I know this is a lot of information at once. If you have a small sample size, by which I mean, maybe like 5 people in a single cell here, that's when you would use what's called a Fisher's test. So this correct is really based around the sample size that you're dealing with, but I just kind of want to make that caveat because sometimes if you're trying to reproduce something, you might find that the results are not identical, and that may be why you're seeing that. So now that we've looked at that, we've identified that there is a significant relationship between low birth weight and maternal smoking. What about the continuous version, right? So for those of you who took my class in the fall, you know that I'm a huge fan of box plots. So in this particular case, if you want to visualize your data, what you would do is you would use the box plot function. And then again, B weight is the name of the data set. And then we'll use a $ to get our column name, which in this case is weight. And then we'll use this tilde to basically say, weight is our outcome. We're interested in stratifying it by mom smoke is the name of the other variable. So you can see I have my $ here. And then we get this nice box plot. So we can see is that just like our summary measure before, the 0, which again is mothers who did not smoke during pregnancy, we tend to see a higher kind of average infant birth weight versus the mothers who did smoke. And a lot of kind of, you could call them outliers. So it depends on how this is defined, but generally speaking, this line right here will be your median value, and then you'll have your quartiles. And then these upper bounds can sometimes be like 95% and 5%. It will depend. But again, the point is that the vast majority of your data kind of falls right here. And the other thing that I want to tell you about is this summary function. So if you're just exploring your data, I highly recommend this summary because it'll give you kind of a nice representation of all your different variables in one single line of code. So you can see here, it'll give you an overall description of weight. And then for your more categorical variables, it'll be a little less informative, right? Because they're not actually meant to be treated as continuous. But the major point that I want to make here is that if there was any missing data, it would say NA equals, and it would tell you how many missing variables you had. So for the data set, which is B weight, which is the data set in which we actually have weight as a continuous data set, unlike the other data set, we don't have any missingness. We don't have to remove anything, which is nice. Again, if you took my class in the fall, you know that I'm a huge fan of the QQ plots. And so what I'm going to do here is just show you, again, we're using piping. All I'm doing is saying I just want to look at mothers who were smoking, and I just want to look at the weight variable. So what we get here is we get, generally speaking, again, we're trying to see if the data is normally distributed. In this particular case, what we can see is that there's kind of this really large deviation, which implies that there's maybe some skewness going on for the lower part of the data set. And then if we run it again for the mothers who did not smoke, we see a similar distribution. So despite the fact that we have a lot of data, like 50,000, you could argue that this is non-parametric. So again, I know this is a lot of information, but generally speaking, if you assume normality, You'll use a t-test. If you assume that things are not normally distributed, then you can use what's called a Wilcoxon test. So in order to do that, you just use the wilcox.test function. And then again, we're interested in the relationship between weight and mom smoke. And what you can see is we get a highly significant result, probably largely influenced by the fact that we have a lot of data. So in this case, we can see that there's a significant difference in birth weight between moms who smoked and those who didn't. If you did conduct the t-test, the point that I want to make is that there are two big assumptions that you want to keep in mind. The first one being that it's this normality assumption, which in this case, maybe we argue that this is violated because generally speaking, we want our data to follow along this blue line here. The other big part of conducting a normal or a t-test, you also want to make assumptions about the variance. And so generally speaking, a t-test assumes that your variances are equal. The other point that I want to make, and this is different than with SAS, with R by default, it assumes that the variances are not equal. And so if you want your variances to be equal, or you conduct what's called a variance test to determine whether or not your variances are equal, in this particular case, we got a significant result, which implies that the variances are not equal. And then what we would do from there is we could run our t-test using our t.test function. And then we would set our var.equal to either true or false. And again, by default in R, it assumes that they're not equal. But the point here that I largely want to make is that the format is identical, right? So it's b weight, $weight, tilde, b weight, $smoke. It's exactly identical for both your t-tests and your var tests. So I hope that makes you feel a little bit more comfortable, at least with how things are set up. So let's switch gears a little bit. We're looking at the relationship between city miles per gallon and highway miles per gallon. What I've done here first is I've created a histogram. And what I'm interested in is I'm interested in that actual difference between the two measurements, right? So if when we load the data, what you can see here is that each car has both a highway miles per gallon and a city miles per gallon measurement. And I'm interested in the difference. So if we subtract the difference for all of these, and then we look at kind of a summary of it, what we can see is that the vast majority of data is greater than 0, which implies that highway miles per gallon tends to be larger than city miles per gallon. Again, perhaps not surprising. Just like we did before, we can create a QQ plot. Generally speaking, you kind of want this QQ plot to be like a 45-degree angle. This is kind of behaving a little bit differently. The reason why it looks like it has these flat lines is because you'll notice that all of the data is actually integer, so there's no decimal points. But again, the point that I want to make is like, I'm not convinced that this is something that I would use a t-test for, but at this sample size, it probably won't make a huge difference. But so I would conduct my Wilcoxon test here. Again, the difference here that I'm making from before is I'm saying, I want to take the miles per gallon highway measurement, and I want to take the miles per gallon city measurement, and I want to pair them. So I want to say, is there a relationship between the two variables? Is there a difference? And what we see here is significantly so. In the bottom, we have a p-value of less than 2.2 times 10 to the negative 16th. That is way less than 0.05, implying there's a difference. Which again, probably isn't surprising, right? We know that generally speaking, the highway miles per gallon is going to be higher than your city miles per gallon. And in fact, with our data, with the exception of one person here, that tends to be the case. But if you were to do the t-test, again, it's the same exact format as the paired test. So you just need to add this paired equals t argument here. And again, we're interested in miles per gallon highway, miles per gallon city. So we can conduct that test. The point that I want to make here is all three of these are actually identical. So, and again, I won't get too in the weeds with this, with the statistics here, but what we're doing here in this first one is we're pairing the information. In the second line here, we're actually doing what's called a one sample t-test. So we're subtracting this miles per gallon city from highway but our p-value and our t-statistics all are exactly the same. And then you can actually run a linear model. So a linear model assumes that you essentially, if you run a linear model, which again, we'll talk about in a moment, you will actually get the same result as a t-test. That's just kind of an interesting side note that I only find interesting. So finally, and I know we've got about 10, Lala thinks so too. Okay, good. So finally, we'll talk about height and weight. So if you remember, we had a fictional data set looking at children's weight. We can see here in the bottom, we have height. When we, again, so the sort of structure here, the name of the function is plot. The name of the data set is class. We use the $sign to say, I want to look at the weight column and I want to look at the height column. We use the tilde to say weight is going to be my y-axis, kind of like a standard function. X is going to be my, or height is going to be my x-axis. So you can see that here. What you can also see is that this is generally, positive correlation. It makes sense. Generally, the taller you are, the more you weigh, at least for school children. At least for this fake example of school children, I guess, with only 19 measurements. And then from there, again, because we're looking at what's called a linear model, we have to make assumptions about the normality here. So if you look at the data, again, this is data, right? Not all data is going to be perfectly normally distributed. If I look at this overall, I'm pretty pleased that this is reasonably normally distributed. Again, rarely in practice are you going to find a perfect bell curve in all of your data. So I'll kind of show you how to look at your results and see if you think that's reasonable. So what you'll do here, again, kind of similar setup as before, but what we're doing is we're creating an object that's called LM1 or linear model 1, and then we're using the LM or linear model function to basically say, I want to know what the relationship is between weight and height. And then we're going to run that. And then we have to create this new line that says summary. I want to know what the results are. So what you can see here is that we get a highly, highly significant p-value implying that weight and height are highly related to each other. And the way that you would sort of interpret this is for basically every 3.899 increase, or excuse me, for every 1 inch increase in height, you'd expect a 3.899 increase in weight. And again, that sort of is just a general kind of way to look at the data. And then if you're not sure about this normality assumption, you can do what's, oh, Lala, yeah.
I got a question in the chat box that I wanted to read to you.
Yeah.
Does it matter to list the dependent or independent variable first in your linear regression code?
That's a great question. So yeah, so you will always need to put the dependent variable. And in this particular case, right, we're just interested in the relationship between two variables. And so you could swap them and you would still get a significant result either way. But for example, like if you're interested in looking at different variables, right? Like if we wanted to say like, I'm interested in weight as my outcome, right? As my dependent variable. And I'm interested in the relationship that both height and sex impact. In that particular example, you'll always want your outcome to be on the left side. And then Lala, do you have another one or was it just that one? Okay, cool. So I hope that answers your question. And then you can use what's called this plot function and you can put in your linear model. And what you'll get is you'll get these little plots in the right that kind of tell you overall how your data looks. Generally speaking, this is pretty good. Again, relatively small sample size, but you're looking for the data to more or less fall on this line here. You can also look at a histogram of your residuals. So I'm going to run that here, which again, doesn't look great. Again, traditionally speaking, you're assuming this kind of follows a bell curve, but we kind of have a small data set. And then the other point that I want to make is that when you can also do what's called a correlation. So simple linear regression is looking at basically the relationship between two variables. so is a correlation, right? So if you were to use what's called the core.test function, you get the same exact p-value that you would have gotten had you done the linear model as well. And then if you see this and you're like, well, it's a small sample size, I'm not convinced that this is, normally distributed. All you would do is you would use the same exact function, core.test, and then you just have to use this method equals Spearman argument, and then you run it again, and you still get a significant result. So we're running out of time. Let me switch back to the slides here. I just have a couple more things. So I just want to say R is difficult to learn, right? So I've put some resources here. Swirl is a very cool resource where you actually, I won't show it here, but you actually can open up R and then it'll give you commands to type in like in real time. And it's a really cool way to learn R. And then R for data science. If you click on this link, this is a totally free textbook that you can use, and it has real coding examples. And then finally, I'll just leave you with this. R is like learning a language. You have to practice regularly. I'm super happy that all of you are already, it sounds like, starting to download the data and are playing around with it. That's awesome. If you do have questions, you're more than about running this. If you run into errors, you're more than welcome to email me. But again, you really kind of have to start working with it. So I recommend that you can maybe start like a data set that you have analyzed in Prism or Excel or wherever it is. Try to do the same thing in R and see how it's different. And I think that's a helpful place to start. So from there, I will open up for questions. And I know that we had one more. Let's see. So if you missed any part of the seminar, we will share the recording. So thank you for sending that. Oh yeah, so in the fall, so next fall, I'll be teaching a short course that gets more into the kind of specifics of this. So if you're interested in that, there will be mailers just kind of like you saw for the CETA Data Week. And it's called basically Data Science and Statistics for Bench Scientists. And again, it's a 6-week short course. We mostly administer it virtually. Thank you, Lala, for putting the link there. So if you're interested in learning more, I highly recommend that you check it out. I love teaching that class. So yeah, so there's that. And then let's see, there was the question about, let's see. Yeah, so Stephanie had a question about, it's saying B weight not found. So generally speaking, when that error happens, that means that the data is not in your R environment. So what I would recommend is that you make sure that, and it could have been the way that it got named. So I would make sure that you can open up the data set and you can actually click on, so I'll switch back here to my environment, back to my R screen. So again, once you've gotten to the point where you click import data set from text, again, doesn't matter if it's .text or .csv, make sure that the name here is something that makes sense, and then it should import, you should see it in this top right corner. So if you don't, a lot of times it's like a spelling thing. So that would be my first recommendation, to check that out. Okay, great, awesome. So any other questions while we're kind of wrapping up here? Let's see, should we use Library Reader to read in? You definitely can, yeah. So the question was, should we use Library Reader to read in the data? So that if you look here, import dataset reader, they're going to be identical. So it's they'll look a little bit differently, but yeah, they will essentially, they're doing the same thing. And then we had a question, what about the 5 p.m. class today? So the 5 p.m. class today is using R as well. And that class is looking at kind of like, how do you make interesting figures, right? One of the cool parts about R is that you have a lot of flexibility when it comes to making figures that you may not have like in Prism and Excel. So highly recommend that you check that out if you have time. And then again, got a couple more minutes for questions. Thank you all for your time. I will put my email in the link here, just because if you have any specific questions about the specific content that we've gotten into today, I'm more than happy to help answer those questions. So there we go. All right, well, it's 1 o'clock. Again, I hope you all learned something. I know it's a lot of information in a short amount of time. So again, make sure to download the code, play around with it. Let me know if you have questions. And I hope you're able to attend some of the other talks throughout the week. Thank you. All right, I'm going to stop recording here.